Thank you. Welcome to the Dungeons, which seems like an appropriate place to discuss PHP internals. My name is Adam Harvey. I work for a company called New Relic. We do performance monitoring stuff. There's a bunch of other stuff I'm probably supposed to say to plug it, but we're awesome. Just go check it out. And outside of that, I work on PHP, the PHP documentation, the PHP website, a bunch of PECL extensions, and pretty much anything else I've been guilted into in about the last decade. So I'm here to talk to you about porting extensions to PHP 7, which is a talk I originally called Welcome to the New Age, and then immediately thought of a better title 5 minutes after I sent it in. So, it would help if my clicker clicked. There we go. So let's talk about PHP 7. It came out in December 2015. It's kind of been a quiet thing, but maybe you've heard of it. In userland, not much changed in PHP 7. If you have a well-written, pretty modern PHP app, it generally works more or less on PHP 7 without having to do any significant work. Maybe less so if you're a WordPress user, but for the most part, it just works. For internals, however, there was a significant amount of change. Between the API exposed by the Zend engine and PHP in PHP 5.6 and PHP 7, 333 functions were removed, and macros were removed, which is almost exactly 25% of those that were exposed in PHP 5.6. 410 new functions and macros were added, so there's some new stuff. There are APIs to deal with that. But perhaps the bigger problem is that 516 out of the 990 functions and macros that kept the same name and stayed in PHP 7 changed somehow. And this actually excluded thread-safe noise, which I'll come back to later. This is like actual changes, type changes, parameter changes, those kinds of things. That's kind of a lot. Now, a lot of these are kind of internal functions that, in general, if you're writing an extension, you don't need to care about, unless you're writing a profiler, in which case your life will have been like mine has been in the last 9 months, and you probably have started drinking heavily. Most of them don't matter. But some of them really do. And you need to know what you're going to look for. But first, now I've thoroughly terrified you, the first question is really, what do I do with my PHP 4 or 5 extension? How do I migrate it to PHP 7? Well, you've got a few options. You can do a one-way migration and just port your code to run on PHP 7 and forget about PHP 5 and use all the new hotness. That definitely works, particularly if you've got like an internal extension that just runs your site. Like if that's the only thing, why wouldn't you do that? You can run separate branches. You can upgrade and basically use compatibility shims, macros, preprocessor magic, etc. to run PHP 5 and PHP 7 code. I guess there's also a fourth option. It's probably not a very good one, but it's an option. So let's just look quickly at the advantages and disadvantages of each. If you make a one-way migration, your advantages are pretty obvious. You only pay the cost one time. It's relatively easy to maintain the extension later. It's conceptually pretty simple because the concepts don't change a lot, but you just deal with how PHP 7 behaves for things like objects and resources. And you also end up with nice clean code, well, by PHP extension standards. So it's still terrible, but it'll be slightly better. The disadvantage is a pretty obvious one. You no longer support PHP 5. Now, as I said, if you have an internal extension that literally only runs on your site and you're going to just do like a flag day migration to run your site on PHP 7, that's fine. Not a problem. Job done. But if you're doing PECL extensions, if you're doing anything open source, if you are even doing closed source stuff that has to run across versions, this doesn't really work. It's not really going to be an option. So option 2 is to maintain parallel branches. The advantages are pretty obvious. You get to support both versions, and you actually get the best of both worlds in terms of you'll have idiomatic code without ugly macros and compatibility hacks that works in both PHP 5 and PHP 7. However, I'm not a big fan of this one because maintenance becomes a pain. You might have just doubled your work in terms of maintaining your code for bug fixes. Now, if it's a small extension, maybe that doesn't matter. Maybe you can do that anyway. But if your code is actually that simple, maybe you should just have it support both versions anyway, because why not? And of course, branches may diverge over time. This is one of those things that I know for Python developers, when the Python 2 to 3 migration has been happening, this was one of the options that people sometimes went with, and I don't know of anyone for whom it worked out. It was always a nightmare in the end, so I would not recommend this. Your other option is to do things the PHP way and to hack things until they work on both versions. The advantages of this are pretty obvious. You support both versions, your maintenance overhead is somewhat less because you only have one branch compared to two, and you have happy users because it means that your installation instructions aren't, well, you do this if you're on this version, or you do that if you're on that version. You just go, if it's a PECL extension, you just go PECL install this, and it works, hopefully. The disadvantages are now you are exposed to having to support the APIs that changed. Remember how I said there were more than half of the APIs that are in both versions have changed? You get to deal with that. I still actually think this is the best option if you're maintaining an open source extension or something that you're selling to customers, but there is pain, particularly when you do the initial port to support both versions. So let's not pretend that it's an easy, straightforward process. So as I said, I think I'd go for option 3, which is support both, but your mileage may vary. So for the rest of the talk, I'm mostly going to talk in terms of supporting both versions, but at the same time, the changes I'm highlighting are also things that you need to know about if you're doing a one-way migration or separate branches. These are basically, I'm going to try and run through the key hotspots that I've found when porting extensions to support PHP 7. Things that have broken, things that have changed, things that have been removed. In general, I'm going to give you functions and macros that you can go and grep your code base for and then be like, okay, I need to look at this. And in a lot of cases, you're going to need to look at every place that you do stuff, which is unfortunate. But on the bright side, you're going to do a really thorough code review on your code, and you're probably going to find bugs, because God knows I did. The best thing to start, no matter what you're going to do, is to take your extension and attempt to build it against PHP 7. It will fail. Let's not sugarcoat this. You will find out what the limit is on the number of warnings and errors that your compiler will spit out in one sitting. This is the first page of about 10 pages of output when I did this with the Radius extension, which I recently ported to support PHP 7. On the bright side, Clang has really good diagnostics now. It's very easy to read. You can see most of these, and actually I think all of these are resource related, and I'll be touching on resources because they've changed quite a bit, but let me assure you there was lots of other stuff too. So the compiler errors guide you pretty well. There are a few insidious things that will not generate compiler errors, which I'm going to talk about. Those you just have to find by hand, and that sucks. But on the bright side, your comprehensive 100% coverage test suite will pick all of those up. So let's talk about what you need to know. We'll start at what do we need to look for when we're migrating the extension? Well, let's start at the bottom and work our way up. Z-vals. Everybody knows Z-vals. It's the fundamental C structure that underpins variables in PHP. In PHP 5, it looks approximately like this. This is a simplified version. You can tell it's simplified because it just fits on the slide. But it's conceptually pretty simple. There is a type, there is some ref counting stuff, and then there's a union that basically, depending on the type, has the actual value of the variable. It's not particularly difficult. It's pretty straightforward. So the good news is it's still called Z-val in PHP 7. The bad news is that apart from the type field, every single aspect of this has changed. How does this matter? Well, in PHP 7, what's changed is there is an anonymous union with an anonymous struct which has a whole bunch of housekeeping information, but the only one that matters is the type. And the value's been moved to a separate union, but a union that comes in by value. Now, I tell you this not so much because this is directly relevant generally, because in general you're going to use macros to actually access the fields in Z-vals. There's, zstr, zlong, etc., zval long to set, etc. But you do need to know that it's changed, because if you do anything that pokes around in the Z-val itself without using the macros, your life is going to be bad. Your life was probably already bad, but it's going to be worse. Some of the types have changed underneath. So besides where the values are actually stored having changed, the actual types that are used to represent them have also changed. So integers in PHP 5 were the C standard long type. In PHP 7, it is this thing called zend_long. The reason for this is because Windows, 64-bit Windows is a special snowflake. 64-bit Windows still has a long type that's 32 bits, basically so that they can maintain compatibility with business applications that were written 30 years ago. That's okay, it's a reasonable choice. But what it meant was that PHP on Windows, for the few of you who probably do that, basically had no way of representing a 64-bit integer until PHP 7. Now it does have a way of representing it. The problem, and I'm going to come back to this, just something to think about. Think about Zen parse parameters where you pass in variables by address and basically using var args, and Zen parse parameters basically just knows what size each variable is. If you're giving it a long and it thinks it's a 32-bit long and it thinks it's a 64-bit value, you probably just overwrote something important. Another type that changed is isBool. In PHP 5, isBool still used the long value. It was just if it was non-zero, it's true. If it's 0, it's false. In PHP 7, it's been separated into two different types. There is now isFalse and isTrue. I am told this is a performance improvement. The important part is there is an API function called zendIsTrue. And the zval bool macro still exists to set a Boolean value. Strings. This one's a little bit more interesting. So in PHP 5, there was a fairly simple struct, which was a character pointer and an integer. A signed integer, I will note. I have never found a use for negative string lengths, but in PHP 7, there's a new type, and this is a common thing in zvals in PHP 7, where it's not a simple C type. Instead, it will be a pointer to some other type that is managed separately. In general, if you're using the macros like string length and string value, this doesn't matter a ton, but it is something that you still need to be aware of because the ref counting stuff has moved on to the individual types, which means that you no longer have macros to add or remove, to increment or decrement reference counts on an actual zval. You have to do it on the actual type of the zval. So there is a Zend string addref and Zend string delref function. If you want to do it on an object, you have to do the same there. If you want to do it on a resource, you have to do the same there. This is, in general, an improvement, but it does mean that if you're doing anything in terms of manually handling reference counts on zvals, you will now have to actually migrate that to use the new functions that have been provided. It is quite different. There is obviously a whole set of API functions to do with Zen strings if you need to deal with them directly. There is the usual kind of C-style fake object orientation where you prefix stuff and then you have like an allocator and a releaser and so on and so forth. As I said, there are reference functions and there's a couple of like just helpful macros just to grab stuff. Now the problem is, if you're dealing with Zen strings directly and you want your code to run on PHP 5 and PHP 7, you're basically going to have to re-implement a bunch of this. So my advice would be try not to deal with Zen strings directly. If you work on an extension that gets deeply into the Zen engine, you'll have no choice because everything in the Zen engine is now a Zen string. But if you're just dealing with variables and you're just sort of marshalling data into and out of a library, you can probably get away without knowing this. Something you will have to know, though, is there's about 16 functions and macros in PHP that deal with basically taking a string, a character pointer, and turning it into a string zval, whether it's directly or indirectly because you're adding it to a hash table. All of those in PHP 5 have this duplicate parameter, which basically is used to indicate whether you want to duplicate the string or not. In PHP 7, you don't have that parameter anymore. It just always duplicates. There are ways around this if you're using a low-level API, but generally you don't do it. So if you're trying to write code that will run on both, you've now got a problem because when you call return string, it expects two parameters. It expects two parameters on PHP 5, but it expects one parameter on PHP 7. So for some of these problems, you can basically hack around it using macros. Now, I'm going to show you some examples of how you do this. At the end of the talk, I'm going to talk a bit about tooling, and there is actually a compatibility library out there that you can get that will do a lot of this for you, so you don't necessarily have to go take this code from the slides and copy-paste it into your project and actually do it. But I do want to kind of show you how the sausage is made, because the compatibility library, and I think any compatibility library like it, is not going to be very comprehensive. There's just too many weird corner cases, it's too quirky. At some point, you're going to have to know how this works. So this is the kind of thing that you end up doing. You basically end up grabbing the macro definition from PHP and turning it into a macro, and possibly redefining a macro. If you do this, you want to make sure that your header is the last thing that's included, because if you do this before you include some headers that ship with PHP, it's going to be fun. Don't do it. Objects have also changed. Same kind of thing. Instead of having an anonymous struct in the z-val, it becomes a pointer. The new structure basically looks kind of like the old one. It's just got the ref counting stuff again. So again, there's a set of functions to deal with that. This is going to seem really familiar now. Resources. In PHP 5, resources were just an integer value, which was an index into a linked list. Is it a linked list? I think it's a linked list of active resources. In PHP 7, it becomes a first-class type with its own structure. And importantly, it actually now tracks the type of the reference. In no version of PHP to date has the type of the reference actually been tracked until now. This, I am told, is a source of very entertaining bugs. And there are a couple of new types that you should just know exist, but you probably won't use generally in anger. Is undef, which is for new variables that are undefined, and is reference. So because reference counting doesn't happen on the z-val anymore, what happens is, if you have a reference to another variable, the first reference is a variable of type isReference, and there is basically a Zend reference pointer which points to another z-val, and has the garbage collection information and ref count on it. So nifty, only really important if you're doing by reference parameter parsing or by reference return values, and if so, why? Please don't. So let's look at some other things that you need to audit. So I said parameter parsing. All right. PHP 5 code. There is a character string and an integer, a signed int, as I said. PHP 7, there is a string and a size t. Now, size t on most 64-bit platforms is going to be 64 bits. Int probably isn't. It depends on your platform. This is by far the #1 cause of weird crashes that I have managed to perpetuate on myself so far when porting extensions to PHP 7. You have to go through every Zend parse parameters call, literally every single one, because string lengths have changed type and long values have changed type. And they also may have changed size, and if you get it wrong, the compiler will not complain. This is not checked at compile time. Zend parse parameters will not complain because it doesn't know what you did. Basically, you will know this when you get seg faults. And then you will go into GDB and you will look at the data and you'll be like, this is a memory corruption bug, this is weird. And then you'll go into Valgrind and Valgrind won't help you, and it's really bad. So do yourself a favor and just go through all of the Zend parse parameters calls up front. The way that you work around this, or the simple way of working around this, really is to type def basically a type that is the correct thing for string lengths on each version. So for PHP 7, it's a size t. For PHP 5, it's an int. One slightly unfortunate thing, which I really wish I'd thought of 12 months ago and we still could have added it to PHP 7, there's no single macro that just says major version of PHP. So you end up basically writing a lot of if statements like this where you're comparing the module API number, or you do what everybody actually does in practice, which is you have one of those and then you hash define PHP 7 or something like that, and then do if defs based on that. Either way, you end up with the correct type and you don't get weird crashes. You probably do get weird crashes, but not from this. Similarly, you can do the same to define Zend long and basically just monkey patch PHP 5. And I would definitely do that too, because Zend long's not going to conflict with anything. Arrays. Arrays have not changed a ton, but they have changed, well, actually, they have kind of changed a ton. The z-val side of it hasn't changed. The Zend hash side of it has. Different adjective, which I probably can't say due to the code of conduct. So, this is a good one. Array keys in PHP 5. This would have been a good pop quiz. I wish I'd phrased this differently on the way in. Array keys on PHP 5 include the null terminator in their lengths. I don't know why. No, I'm just looking at other people who might know this. I'm genuinely curious why. Anyway, in PHP 5, they included a null terminator. In PHP 7, they do not. So your key lengths are now 1 less than they were in PHP 5. However, that's not so bad because all of the Zend hash functions now actually take Zend string pointers instead of bare character arrays and sizes. That's good and bad because what you'll also notice is that the number of parameters that you provide Zend hash update has now gone from 6 to 3. So that's good, but it means it's going to be a pain to try and get compatibility across the versions. There's also another aspect to this too, and actually I'll just go back for a sec. So in PHP 5, we provide the actual size of the thing that we're stashing in the hash table, which usually is just a pointer, but sometimes it's an actual structure. In PHP 7, we don't. We just give it a pointer. In this case, we give it a zval pointer. The reason for this is because hash tables in PHP 7 now only contain zvals. They, by definition, do not contain void pointers, they contain zvals. So if you're stashing arbitrary data in there, which we did at my job, so that was kind of painful, then you now have to refactor this. The good news is that zvals now have a new isPointer type, which is a nice internal type, which basically the value for which in the zval is a void pointer. There is also a set of convenience APIs for Zend hash, which basically append underscore pointer to every call, and then you put in a void pointer and you get back a void pointer. So it's actually an improvement in terms of the API. It's a lot easier to use. But the downside is that you now, if you're trying to support both versions, you now have quite a lot of work ahead of you because you're going to end up writing something like this for every single hash function that you use because they've all changed. You're going to wrap every hash function basically so that you can pretend that there's a single hash API that works on both versions. I mean, you can add the pointer versions to PHP 5 pretty easily because they won't conflict with anything, but it doesn't help if you're dealing with zvals in hash tables. And if you do anything with arrays, you're dealing with zvals in hash tables. So either you write a bunch of wrapper code or you pull in someone else's wrapper code, but either way, there's going to be an extra level of indirection here. There is one piece of good news though, and this is mostly something you'll get if you do a one-way migration, but there is a compatibility header that adds this to PHP 5. This is the boilerplate to iterate through an associative array in a PHP 5 extension. You haven't actually done anything with it at this point. This is literally just to the point of getting the value and the string key. This is the same code in PHP 7. So there's a whole bunch of boilerplate that's no longer there. You have a really nifty macro, and it actually almost looks like, if you squint really hard, it almost looks like PHP code just with some types. This is really good news. So if you're doing a one-way migration, I strongly recommend that you get rid of anything that calls Zend hash internal pointer reset and replace it with this. Or you pull in a compatibility header and you write PHP 7 style code for both PHP 5 and PHP 7. Every compatibility shim I've seen has basically been written under the assumption that generally you will write PHP 7 style C code. The reason for that is twofold. The obvious one is that when you drop PHP 5 support, you don't have to do much work. The other one is that the PHP 7 APIs just generally make more sense. So you generally want to write PHP 7 code where you can. So I mentioned resources earlier. They're weird holdover things. So resources are a very old PHP thing. They're at least PHP 3 they date from. It might even be earlier than that. I don't know, I'm too young for that kind of thing. Resources in PHP 5 are, as I said, integer indexes into a list. And all a resource is, just in case you've never actually used them, which is probably a good thing, is basically a void pointer of whatever you want. So whatever your context is from your C library, you can just basically wrap it in a resource. It's actually, I know there's a lot of hate for resources on the internals mailing list. I actually think they're kind of wrong. I think resources are kind of cool, but they're not very object oriented, so they're not cool apparently nowadays. So in PHP 5, there's a set of macros which map to basically these functions. And then in PHP 7, there's no macros, and you're expected to use the functions directly. Now, The basic workflow hasn't really changed. You register a resource by registering a pointer that you would like to keep track of. You fetch it when you want it, and then you delete it when you're done with it. That's pretty straightforward. In PHP 7, it works the exact same way. The only difference is you call zenlist close instead of zenlist delete because the resources are ref counted themselves now. As I mentioned, this is now delegated down to the type. The problem is that there are behavioural differences between the functions with the same name in PHP 5 and PHP 7. In PHP 5, zen_register_resource will set the z-val that you give it to be the isResource type and put the index of the resource into that z-val. In PHP 7, you don't give it a z-val at all, it just gives you a zen_resource pointer that you then put into your own z-val at a later date, assuming you choose to. So this makes writing a compatibility shim really hard, as it turns out. It's nigh impossible because you have this behavioural difference. Now, you can write a set of macros that will look like the PHP 5 macros and will basically mimic the same behaviour. I don't know how I feel about this. I mean, as I just said, normally compatibility layers for this are targeting PHP 7 rather than PHP 5. But this is kind of easy. What I did in the PECL compat library, which I'll talk more about later, was to write a separate API on top that basically just gives you the basic operations with much simpler types. And that's probably what I'd really recommend you do unless you do a one-way cutover. That's a rough version of the macros. You could copy-paste that. It may or may not build. I haven't actually tried it. It probably works. The other fundamental type when you're writing an extension that wraps a C library is objects. Basic object handling, mercifully, is basically unchanged. The one and only change I've found in the one extension I've ported so far that has used objects has been that when you call zen_read_property, this is a rare case of the PHP 7 API making less sense than the PHP 5 API. You have to provide an additional copy of an additional pointer to a z-val. When I first encountered this about 9 months ago, I actually couldn't figure out why this was the case. And I looked at it again today because I was writing my notes for this slide and I really didn't want to stand up here and be like, I don't know why that is. The reason why that's the case is because if the object has a custom getter, so __get, the return value that is returned, because PHP 7 does so much more stuff on the stack rather than the heap, actually doesn't have any storage space. You're giving this pointer you should never use for anything. You are simply giving it space to return the value. You should ignore the value that gets put in there and you should actually use the value that gets returned, because if it's a real property and you're not using a getter, this never gets touched. I don't know. So you can write a compatibility layer. Yeah, that one's just weird. I don't get it. I assume there was a really good reason that I'm not smart enough to understand. So you can write a compatibility shim that adds that parameter and just doesn't do anything with it in PHP 5, because in PHP 7 most of the time nothing happens to it. Incidentally, I also found a bug in the code I work on as a result of this, so oops. Then there are less simple objects, so custom objects. Pimped out objects, where you have custom allocators because you're attaching some other piece of data, another pointer, another structure, something to your object. Now, this has gotten a little bit more interesting because, as I kind of skipped over earlier, the Zend object structure is now variable length, because properties that are declared on the class are now actually stored in line with it, because this improves cache locality and therefore performance. This is really cool. The catch is that means that writing a custom allocator and accessing custom pointers associated with objects has just become a lot harder. This is another rare case where the PHP 7 API looks way worse than the PHP 5 API. And if you're trying to support both, good luck. So this is how you did a custom allocator in PHP 5 approximately. I had to reduce the size of the text on this slide slightly, I apologise, and I still skipped like 6 lines of boilerplate. The important thing really is that we malloc the size of that structure, basically, because we know how big the Zend object is in PHP 5, we get a handle that we return and we return it. And then when we want to access the pointer to the myStruct, which is whatever we've gotten back from our C library, it's really easy because that's what we actually stored in the Zend object store. So all we have to do is we just have to cast it when we get it back out, and we can access our fields, and life is good. Okay, PHP 7. Because the Zend object is now variable length, it has to be the last field in the structure if you're using a structure like this, which is the normal case. So we've reordered the structure fields, which normally isn't a big deal. But because it's variable length and the size depends on the number of properties that are pre-declared, the emalloc now is the size of the object plus the return value of this helper function, which is not super complicated. Against that, you no longer put anything into the object store directly. PHP will take care of it. However, the catch is that all you give back to PHP is the pointer to the Zend object. Anything before that you've put into your object structure, PHP doesn't know about, except for one case where PHP does know about it, which I will mention in a second. So what this means is that when you want to get your original structure back, instead of just casting what you get back from object store, you now have to take the pointer to the Zend object and do some maths. You know that the pointer to myStruct is size t bytes before, it is 4 or 8 bytes before the pointer to the Zend object. So you use this xt offset of macro, which is a very old wrapper for the C standard offset of macro, and I don't know why we don't just use that. I blame probably some ancient Unix I've never heard of. We have to cast the object to a character array because offset of returns the offset in bytes. And then we cast the whole thing once we actually think we're at the right place back to my object. Remarkably, this works. So the good news is that you can actually do this pretty easily. So the getter's a bit more complicated. There is one other thing though. When you register the class, which is the normal, this is again just a cut down version of the boilerplate that every extension that does this has. You register the class, if you're doing custom stuff, you usually set up your own custom object handlers because you probably have to. You now have to set this field called offset. And offset is the number of bytes into your structure that the Zend object pointer is. So it's the same, it's basically the positive version of the same offset that we just used. Here's why you have to do that. So when you register a custom allocator, you usually register a custom deallocator, and traditionally you've freed the stuff that you mallocked in the custom allocator because that's just a good thing to do. And it avoids warnings when you exit in debug mode, which is also useful. PHP 7 tries to be helpful. After the deallocator is called, you don't have to free your structure anymore, that myStruct that I had, because PHP will use this offset to go backwards and call free on that value. I don't know why that was thought it was a good idea. That just seems like it's being done at the wrong level, but that's what's happening. So you don't have to call free in your deallocator anymore, but of course you're still going to have to call free on anything that you allocated or close or whatever the right function is. So I'm not really sure what the win was here in terms of moving that. But you have to be aware of it because if you don't set this offset, it will obviously be a junk value, and then it will attempt to free a value that you never allocated, and your extension will crash. The last change I'm going to talk about, there are more changes. If you call back into PHP code using call user function, God, good luck. That changed completely. But the last change I'm going to talk about is the one that renamed the talk. And it's simply that if you are writing PHP 7 only extension code, you never have to write any of this again. It will take you at least 10 years to get out of your muscle memory. At least that's my assumption, because I assure you I can still type these in about half a second each. But you no longer have to include them in your code if you are writing PHP 7 only code. So finally, I just want to talk about some references and some tools that I've personally found useful when I've been migrating extensions. I've worked on the project to migrate the New Relic extension, which is kind of the basically migrating a profiler to run on PHP 5 and PHP 7. That was interesting. And I've done some simpler PECL extensions as well, and these are the resources that I've used. The first and most useful one is this page on the PHP wiki, which is PHP-NG upgrading. If you Google that, it'll be the first thing that comes up. This breaks down in somewhat more detail than I have in some cases most of the things that have changed. There are a few things it doesn't cover. It doesn't cover much of the object stuff, which is kind of unfortunate if you're writing an object-oriented extension. But it covers almost everything else. And this is really good. It is probably stuff that should be in the manual, and in my copious amounts of spare time, maybe I'll try and integrate it at some point, but it's a really good resource, and it gives you like before and after for a lot of different use cases. It's also a massive page, so like, take some time. If you need to check it, this probably isn't super readable at the back, I apologise, but the important thing is the link. Lexa.php.net, for people who haven't seen it, basically is just a code Lexa that looks at every branch of PHP, or all the recent ones anyway, and you can use to compare definitions of symbols across versions. So if you want to know what Zen register resource looked like in PHP 5.6 and PHP 7, you can do it on one screen and it will tell you everything that changed. This is awesome and a huge resource, particularly when you're getting weird compiler errors and you just want to know what parameter changed. This will tell you. Something else I found really useful is literally just diffing an extension that looks kind of like the one that I'm trying to port. You know, if you're doing an extension that is, say, object-oriented, EXTGMP is a really good choice. It is quite simple. It was rewritten in PHP 5.6 by Andrea Falls, who actually knows what she's doing, and then was rewritten again for PHP 7 to forward port it. So you can just do a git diff on this. You know, check out PHP source, do a git diff, and it will basically tell you every single thing you need to do to port an object-oriented C extension. You will learn very rapidly by osmosis what has to be done. And similarly, if you want to port a resource-based extension, there's about 20 of those in the PHP source. Pick one that doesn't have many source files and just look at that. Or pick a PECL extension and look at that. The final thing I want to talk about is PECL Compat, which is a set of headers written by Francois Lopetre. I apologise, Francois. Francois Lopetre, who has written a set of headers called PECL Compat that attempt to smooth over some of the differences. Where possible, it backports PHP 7 APIs to PHP 5. Where not possible, it usually provides compatibility API. It's not super comprehensive at this stage. It does basic stuff, it does strings, it does at least some of the hash functions, it does resources as of about Tuesday, because that's when Francois accepted my pull request. It doesn't do objects yet, and I suspect Francois would love a PR to do that, assuming I don't get to it at some point. It's not perfect, and like I said, you kind of still need to know what's happening underneath because it won't be perfect. There'll be stuff that you'll still have to know about and stuff that you'll still have to change. But it does give you an awesome head start in terms of doing the work. So for the PECL Radius extension, which I just forward ported earlier this week to support PHP 5 and PHP 7, I just pulled this in as a Git submodule. And that, Git submodules are kind of hacky and kind of evil, but honestly, it works. So I'm probably going to keep doing that because it actually is a pretty smooth approach. You can just include the header, it includes its other subheaders, and then in a lot of cases, half of your compiler warnings just go away straight away. It's pretty cool. The other thing I really just want to say is, don't be afraid. I mean, this is a potentially slightly scary talk. I've talked about the fact that a quarter of stuff is gone, a quarter of stuff got added, half of the rest of the stuff changed completely. Oh God. It looks scary when you first see how much has changed and when you first see how many compiler errors actually appear in your console when you're trying to figure out whether your extension will build or not. But it's not that bad because nothing fundamental has changed. An object is still an object, a resource is still a resource, a zval is still a variable. The Zen hash API still doesn't make sense. Everything is still where it was. It's just little cosmetic changes, which you can work over pretty easily. I mean, look, I ported the Radius extension in a pretty lazy afternoon, and let me assure you that 9 out of 10 PHP contributors agree that I write terrible code, and I submit fput CSV as evidence of that. If you are methodical and careful, and you just look at the compiler warnings, and you look at where you're calling Zen pass parameters, and you look at how your type handling is being done, you will do it no problem, and you will move into the new world, and you will support both PHP 5 and PHP 7 very, very comfortably. And on that hopefully inspirational note, I thank you very much for coming, and welcome questions, heckling, and people telling me I'm wrong.
Thank you very much, Adam. That was excellent. Thank you. Questions? There definitely was a rush of optimism towards the end. I enjoyed it.
Excellent.
For people who don't have the baggage of having written extensions into PHP 5, do you think these changes in 7 make this more approachable? Historically, it's been a bit of a mountain to climb.
Yeah, I mean, it's a really good point. I mean, if you compare your average PHP 4 extension and PHP 5 extension, there was definitely some additional complexity there, which generally wasn't helpful as an extension author. I think it's a mixed bag. I think the hashing changes, as much as I just joked about them, the hash table changes are great. I actually think they make a lot more sense in PHP 7. The way resources are handled is great too. It's a lot cleaner. I think in general, good PHP 7 extension code, and we don't quite know what that's really going to look like yet because everything that exists is just a forward port of PHP 5 code. I think good PHP 7 extension code will be just a little bit clearer than PHP 5 extension code. But it's never going to be great. There's just too much baggage in the API. There's too many weird things happening in the engine. And so, yeah, I think it will be a little bit simpler, but I don't know if it's going to be a lot simpler, which is unfortunate.
So you've still got a day job, yeah?
Yeah, apparently I do.
This may be an obvious question to some, but why do strings need ref counting?
Well, it's basically because ref counting moved off the Z val. It's not so much that the strings themselves need ref counting, it's that for simple types now, the way references are done is just you have actual pointers to the original Z val, and the Zen reference structure does the ref counting on that. For things like, for more complicated types where it's not just a simple value type in the struct, the decision was made to move the ref counting to the actual struct, to the internal struct, I believe basically because it made the garbage collector considerably easier to run and faster. So it's not that strings themselves need ref counting, it's just that any complex type needs ref counting. And strings are a complex type because you've got to track the length as well as the actual character array.
Thank you.
In general, if there's weird stuff in PHP 7, it's almost entirely going to be because it was quicker. Yes. Like, that's going to be the sole motivation. If there's weird, like the read property thing, the reason that's there is because it's quicker. It doesn't make any sense, but it's quicker.
Just an assumption check, really, but I assume you don't need any ref counts for simple values because you're not using any pointers. You can just destroy them straight away. They're smaller than the pointers, so you don't have to actually allocate any memory to them.
Exactly. So in the Zend engine internally in PHP 7 now, pretty much all the Z-val handling, or at least creation and destruction and so on, is actually done on the stack rather than on the heap. So previously you would malloc, emalloc a Z-val or call like alloc init Z-val or something like that to actually allocate it. For Z-vals and simple types in general now, this just internally it just happens on the stack, so that's why there's kind of no ref counting. As you said, it's just smaller and easier and more performant.
So basically, we're just going to have some lovely switch statements while detours and
that's
pointer increases.
The one good thing is, I think honestly, if you're not doing stuff with references, and by references I mean like PHP level references, and you're not doing really weird like internal engine kind of hackery level stuff, most of the APIs for variable handling are actually still the same. So they still take Z-val pointers, they still return Z-val pointers as appropriate. So you're if you've got a simple enough extension, you're actually pretty insulated from that. Like, you kind of still need to know in the back of your head that it's changed, but you don't really need to do much in your actual code. Like, your basic assumptions don't really change about how Z-vals work.
Okay, sounds cool, thanks.
All right, thank you very much once again for coming, and thanks for your attention.
Thank you very much. We have